Hello, students. We are starting a new unit, Unit 9, which is the coordinate plane. And today is lesson 9.1, points on the coordinate plane. And before we get started with our sample problems, there are a few things that we need to go over. And the first is that in our first two, we looked at both the positive and the negative side of number lines. And we looked at two types of number lines, horizontal and vertical. And if you take a horizontal vertical number line and a vertical number line and you lay them on top of each other at 0, you get a coordinate plane. So let's look at the parts of a coordinate plane and kind of see how it works. I'm sure you've seen these before. This is a coordinate plane. And we have our horizontal number line and our vertical number line. This is 0. 0 is called the origin. Origin is at 0 on both the horizontal and vertical. Now on the coordinate plane, the horizontal number line is called your x-axis, and the vertical part is called your y-axis. So I often refer to the x-axis and y-axis. If I say x-axis, I'm talking about this part of the coordinate plane. If I'm talking about y-axis, I'm talking about this part of the coordinate plane. So this is the basics of a coordinate plane. And the coordinate plane is divided into 4 parts. This is a part, this is a part, this is a part, this is a part. And those 4 parts are called quadrants, and they are numbered. So let's look. Here's a couple of notes about quadrants. So here is your ordered pair. I often think, to help me remember where the first, second, third, and fourth quadrant is, I think of the letter C. If you were to draw a big C on the coordinate plane, where you start would be the first quadrant, this is the second quadrant, this is the third quadrant, and then this is the fourth quadrant. So if we look at it a little more closely, this right here is the first quadrant. And the first quadrant has the positive numbers on the x-axis and the positive numbers on the y-axis. This is our first quadrant. The second quadrant, it has the negative numbers on the x-axis and the positive of the y-axis. So that's the second quadrant. The third quadrant is down here, and the third quadrant is the negative numbers on the x-axis and the negative numbers on the y-axis. That's your third quadrant. And then the fourth quadrant is here. We've got the positive numbers on the x-axis and negative numbers on the y-axis. It's not really important that you memorize that. You'll get to working with these and it will make sense. Every point on the coordinate plane has an address, and the address is called the ordered pair. I've got some notes right here, the ordered pair. Now, an ordered pair consists of 2 numbers separated by a comma. So this is a number, this is a number. We've got a comma in the middle and they're in parentheses. So the first number is the number on the x coordinate, and the second number is the number on the y coordinate. So if I have an ordered pair like 2, 3, 2 is your x coordinate, 3 is your y coordinate. This is an address on the coordinate plane. So let's look at our coordinate plane, and I'm going to show you where the address of 2, 3 is. Okay, the first was a 2. We go to 2 on our x-axis, and then 3 on your y-axis. So you go over 2 and up 3. So if you go over 2 and up 3, this is where that point would be. So again, an ordered pair, numbers. The first number is your x-coordinate, the second number is your y-coordinate. Now, these are the basics about a coordinate plane. Let's look at some samples together from our workbook, and we'll do several together, and then you will do some on your own. Okay, so the first question says, give the coordinates of each point. And let's look at our coordinate plane. Our coordinate plane, we've got point P here, we've got point Q here, R is here, S is here, T is down here, U is right here, V is up here, and W is here. And we want to know the coordinates of each point. What is the ordered pair? What is the address? I've taken the liberty of writing these out just for time management. So let's look at point P. Point P is right here. Now the ordered pair, the coordinates are, first you go back or forth on the x-axis, and then you go up or down on the y-axis. So we are starting on the x-axis. Starting here, you would go back 4. So it goes, we're going to go to -4 on the x-axis, and then we're going to go up 2. So we went back 4, up 2. So that is our ordered pair. On the x-axis is -4. On the y-axis, it goes with 2. So the coordinate of point P is, whoops, I almost put +4. It's -4. That negative is important. -4 and 2. Okay, -4 and 2. So let's look at Q. Q is an interesting one because on the x-axis, we go back 3, but then we don't go up or down. We just stick right there. So what do you think the y-coordinate would be if we don't move? Well, we went back 3 and we went up or down. So the coordinates for point Q are -3 and 0. Let's look at T. I'm going to skip over to T because T is interesting. We are not going to move on the X or Y axis. So we are starting at 0, but then we have to go down 3. So since we didn't go left or right, we're at 0 on the X axis and then -3. So the coordinates are, that was point T, 0 and -3. Let's look at U. U is over here. So we start at the origin, and we're going to go along the x-axis all the way to 7. And then from 7, we're going to go down 2. So our ordered pair is 7, -2. So that's what U is, 7 and -2. All right, I would like for you to try R, S, V, and W. See if you can find the coordinates of those points. All right, let's look at number 2. Number 2 says plot the points on the coordinate plane below. In which quadrant is each point located? So we've got 2 things. Now the first thing I want you to notice is the X and Y axis are not drawn on there. We have to draw the X or Y axis, and you need a straight edge for that. Let's see, where did my straight edge go? I don't have a straight edge. That will be hilarious. You know what you do if you can't find a straight edge, or find something that'll work. I think I know where my straight edge is. Be right back. When we get to graphing, a straight edge is an important piece of equipment. You need a straight edge. I'm very picky about straight edges. So I'm using this little mini ruler. Rulers make great straight edges. If you don't have a ruler, then use something else. Use something that you can draw a straight line with. Okay, so I need to draw the X and Y coordinate. And we got to be strategic about this. And I'm not going to get too much into the strategy, but I want you to draw it about where I do. So I am going to draw this. And if you want to use like a colored pencil or something, you may do that. I'm going to draw it out the middle. Okay. So I have drawn the X and Y axis. I don't expect you to label it. You do not have to label your X. You don't have to put 1, 2, 3, 4, and then -1, -2. You don't have to do that. But we are counting by ones. So we are going to graph them and then tell what quadrant they are in. So let's look at S. S says 3, 2. That is the ordered pair for S, 3, 2. That means we need to go over 3 and up or down 2. Now this is positive, so we're going to go up 2. So over 3, up 2. That's what S is. So I'm going to start at the origin. I'm going to go over 3, 1, 2, 3, and then up 2, 1, 2. You put your point right there, and that is called S, and we label it S. Okay, T is at 0, 1, or 0, -1, 0, -1. So since this is 0, we're not moving left or right. We just stay where we are, but we're going to go 1 in the negative direction. So I'm going to go down 1. So 0, -1, we don't move left or right. We just go down 1. That, and put our point there. And that is point T. Okay. U is -4, -2. So we're going to go negative in the negative direction. So we're going backwards 4, and then we're going in the negative direction down 2. So back 4, down 2. So I'm going to start at the origin, and I'm going to go back 4, 1, 2, 3, 4, down 2, 1, 2. And that was point U. Point V, 4 and 0. So in this case, I'm going to go over 4. It's in the positive direction, so that moves to the right. Go to the right 4, but the 0 says don't go up or down. Don't do it. You just go over 4, make your point. So start at the origin, 1, 2, 3, 4. And that is V. I want you to do the same thing for W and Z. I would like for you to graph those 2 points. Now, that is the first part. Plot the points on the coordinate plane. I've done 4 with you, and you do 2 on your own. And then it says, in which quadrant is each point located? Okay, so remember the quadrants. Remember the letter C? This would be first, second, third, fourth. Okay, so let's look at S. Where is S? S is in the first quadrant. So we're going to write first. T. What quadrant is T in? Think about it. What do you think? Is it in the first quadrant? Second? Third? Fourth? It's not in a quadrant at all. So you're going to put none. It is not in any quadrant. It is actually on which axis? It's on the the y-axis. It is on the y-axis. Okay, do you see another point that is not in a quadrant? Very good. V is not in a quadrant. All right. So T and V are not in the quadrants. S is in the first quadrant. What quadrant would you be in? That would be the third quadrant. Very good. All right, so after you plot W and Z, tell which quadrant they are in. All right, so that's 1 and 2. Now the next points, reflections. We need to go over reflections. So let's go back to this. And do you remember our point here? We graphed this point, and this point was 2 and 3. Now a reflection is kind of like a mirror image, okay? And I can make a reflection across the y-axis. This is the y-axis. And if it is a reflection on the y-axis, this is like the mirror. So if you look at this, this is 2 units to the right of the axis, of the y-axis. So the reflection would be the opposite of that. Instead of 2 units to the right, if you go 2 units to the left, this is the reflected unit. Okay? Oops, it's not quite over the -2. There we go. Okay, so this is the reflection. So this is 2 units to the right. The reflection is 2 units to the left. That's across, if this is your mirror, if the y-axis is your mirror. Now, if the x-axis is your mirror, if this is your mirror, then we're looking at above and below. If I'm looking at the reflection across the x-axis, well, this point is 1, 2, 3 units above the x-axis. So we need to do the opposite, and the opposite of above is below. So instead of 3 units above, you're going to go 3 units below. Okay? So I have reflected this point 2 ways. A reflection across the y-axis and a reflection across the x-axis. Now I know that was a very, very quick little lesson, but let's look at this. It says points R and S are reflections of each other about the y-axis. Use the coordinate plane below. Give the coordinates of point S if the coordinates of point R are the following. Okay, so let's go ahead and pull this back a little bit so you can see this coordinate plane. Again, it has no x and y coordinates, so we are going to have to draw it. I would like for you to approximate about halfway and about halfway, and we'll do that. So get your straight edge, and oh, my dog is barking again. And down here, let me let him out while you make your x and y axis. I don't know how loud he is on the video, but he's loud and it hurts my ears sometimes. He sounds so vicious. Okay, reflections. Point R and S are reflections about the y-axis. Use the coordinate plane below. Give the coordinates of point S if the coordinates of point R are the following. So we are going to put these as, we are going to graph these first, and then you are going to reflect them across the y-axis. This is the y-axis. So let's go ahead and let's graph them. We'll graph them together. And they said that this is, each of these is point R. All right, so the first point R, we're going to put at 3, 9. So if we graph 3, 9, we're going to go over 3. And they're both positive, and then up 9. So 1, 2, 3, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8. Oh, wow. 9. Barely had enough room. All right, so this is point R. The other one is -5, oops, -6. Actually, let's reflect it first. All right, so 3 and 9 is up here. Well, S is a reflection about the y-axis. Again, this is the y-axis. So this is your mirror. So we're going here. If this is my mirror, R is how many units away from the mirror? Well, it is 3 units away from my mirror. And I have to reflect it, I have to go 3 units in the opposite direction. So here's my mirror. I go 3 units in the opposite direction. So this is, we call this S. So this is R, this is S. Okay. Now, what is the coordinates of S? I've reflected it. Well, if we start here, instead of going forward 3, we're going to go back 3, but we are still going up 9. So it's going to be -3 and 9. That is what your reflection is. All right. Let's look at -5 and -6. So -5, -6. We're going to go back 5, down 6. So I'm going to come here. I'm going to go back 5. 1, 2, 3, 4, 5, and down 6. 1, 2, 3, 4, 5, 6. This is where R is. Okay, we are still using the y-axis. This is our mirror. So how many units away is R from the mirror? Well, it is 1, 2, 3, 4, 5 units away from the mirror. So instead of 5 units to the left, the reflection is going to be 5 units to the right. 1, 2, 3, 4. So this is going to be S. All right. So our original, we went back 5, down 6. The new one, instead of going back 5, we're going to go forward 5 and down 6. So instead of -5 and -6, it's going to be 5 and -6. Okay? Hopefully you'll start seeing there's a pattern to how these work. 4, I'm not going to do for you. I want you to do 4 completely on your own. But let's look at 6. 6 is 8 and -2. So I'm going to go 8. It's in the positive direction. Forward 8, down 2. All right, so let's go forward 8. 1, 2, 3, 4, 5, 6, 7, 8, and down 2. 1, 2. And that is R. Okay. Now we need to reflect R across, still we're looking at the y-axis. So how far away is it from the y-axis? Well, it was 1, 2, 3, 4, 5, 6, 7, 8 away from the axis, from the y-axis, 8 positives. So instead of 8 positives, we're going to go 8 negatives. 2, 3, 4, 5, 6, 7, 8. So this would be S. And what is the ordered pair for this? Well, we went back 8, down 2. So it would be -8, -2. -2. All right. So in this case, I'm going to actually highlight this. We were going across the y-axis, okay? I should have used a straight edge. Okay, now you're going to do the same thing for this one. Reflect across the y-axis. All right, points P and Q are reflections of each other about the x-axis. Use the coordinate plane below. Give the coordinates of point Q if the coordinates of point P are the following. Okay. So now we are going across the x-axis. I'll take my own advice and use a straight edge. Okay, so I just want this to be a different color so it's a little bit more. So now instead of this being our mirror, this is our mirror. Okay, interestingly enough, this one and this one's the same thing. So we're calling this point P is 3 and 9. So we're going over 3 and up 9. This is now P. We're giving it 2 names. This was R, now it's P. P. Now instead of reflecting across the y-axis, now we're reflecting across the x-axis. This is our mirror. So how far away from the mirror is P? Well, it is 9 units away. So it's 9 units above. So instead of 9 units above, we have to go 9 units below. 2, 3, 4, 5, 6, 7, 8, 9. Wow. Okay, so this is point Q. Well, what is the ordered pair for point Q? Again, we went over 3, and then we went down 9. So it is 3, we went over 3, but instead of up 9, we went down 9. So it's 3 and negative 9. All right, let's look at 8. Oh no, we're not doing 8. We're going to look at 9, negative 5, negative 6. Go back 5, go down 6. So we're going to go back 5, 1, 2, 3, 4, 5, down 6. And this was R. This is now called P. Now, point P is here. My mirror is here. How far away is P from the mirror? Well, it was 6 down. So instead of 6 down, I'm going to go 6 up. That's right. So 1, 2, 3, 4, 5, 6. So this is Q. So if P is, what was it, back 5, down 6, we're still going back 5, but we're now going up 6. So we're going back 5, but we went up 6. And hopefully you're seeing a pattern here. Let's look at 10, 8 and negative 2. We went over 8 and down 2. This is now called P. We are reflecting it across the x-axis. Here's our mirror. So this is 2 below. Instead of 2 below, we're going to go 2 above. So this is Q. So instead of 8 and negative 2, we're going to do 8 and positive 2. All right, I want you to try that last point. It's the same one, negative 7 and 4. Go ahead and graph it and then tell what is the reflection across the y-axis and what is the reflection across the x-axis. All right, that's 10, 11. Now this one, 11 and 12, I want you to try on your own. Let's look at 13. I'm going to get you started on 13. These are a little bit different. It says, for each exercise, plot the given points on the coordinate plane, then join the points in order with line segments to form a closed figure. Name each figure formed. So now they're giving us points. We're going to plot them, but then draw a line connecting them. And it's going to make some kind of point. It's going to make some kind of shape. And we're going to name what kind of shape it makes. So the first thing, we need to draw our x and y axis. And I kind of looked ahead to kind of guide you on where to draw it. And we are going to draw, I want you to draw the x-axis pretty far down, like this. Okay? And then the y-axis we'll do in the middle. All right. So next we are going to graph our points. A says negative 3, negative 1. So back 3, down 1. We're back 3, down 1. We're going to call it A. B is 3 and negative 1. So now we're going to go forward 3 and down 1. So forward 3, 1, 2, 3, down 1. This is B. And then C is our next point, 3 and 5. So we're going to go over 3 and up 5. 1, 2, 3, 4, 5. This is C. And then D is negative 3 and 5. So back 3, up 5. Start at the origin, back 3, up 5. Okay, 1, 2, 3, 4, 5. And that's D. And then we connect them in order. So you're going to take your straight edge. A connects to B, B connects to C, C connects to D, and then D goes back to A. So A to B. I'm sure you can kind of figure out what is this shape even before we connect it. Let's connect it. Right. D to A. All right. What is the name of this shape? Well, what is it? Is it a square? Is it a rectangle? What do you think it is? Well, it looks like a square, but let's double check it because I want to see if this length and this length is the same. So this length from D to C is 1, 2, 3, 4, 5, 6. It's 6 across. And let's see about C to B. 1, 2, 3, 4, 5, 6. It's also 6. So this is 6 units. This is 6 units. 6 units, 6 units. What is that called? That is called a square. All right, I want you to attach these points and tell what it is. Same thing. Just so that you'll know, we're going to leave 3 squares at the bottom. So make your y-axis so you have 3 squares at the bottom. And then we'll go down here. Okay. So graph them, connect them, tell what you got. All right, let's look at the next one. 15. Same thing. I'm going to just draw these. I want you to leave 1 unit at the bottom. And I am being strategic about this. Normally in class, I'd let you explore and see why you want to be strategic, but for time's sake, we're just going to make that. Plot those points, connect them, tell what you have. 16, plot the points, connect them, tell what you have. The X and Y axis can go in the middle of this one. You get a lot of practice plotting points. All right, 17 and 18. 17 is a 3-parter. Let's do 18. Actually, let's draw our X and Y axis on 17. I want you to be a little bit, not quite in the middle, maybe a little bit above the middle for your X axis. And then the Y axis we'll put in the middle. Okay. You're going to do 17 on your own, but we're going to do 18 together. It says plot these points. What kind of triangle is ABC? Figure ABCD is a parallelogram. Plot point D and give its coordinates. Okay, let's draw our X axis a little bit, just slightly below middle, kind of towards the middle, I guess. Maybe it is the middle. I don't know. All right, here we go. 18A, plot points ABC. A is -2, -3. So we're going to go down 2, or back 2, down 3. And that is A. B is 4 and -3. So we're going to go over 4 and down 3. 1, 2, 3, 4, and down 3. 1, 2, 3. This is B. All right, C is at 1 and 4. So we're going to go over 1 and up 4. 1, 2, 3, 4. This is C. All right, and what kind of triangle is triangle ABCD? Let's go ahead and connect those. So what kind of triangle is ABCD? Okay, one thing I noticed about this triangle is that AC and CB are the same length. And do you remember what you call a triangle with the same length, with two sides that are the same length? Starts with an I. It is an isosceles triangle. Isosceles triangle has 2 sides the same length. If this were a little bit longer and you had 3 sides the same length, it'd be equilateral. If all the sides are different lengths, then it would be scaling. Okay, now this is where it gets a little bit tricky. Figure ABCD. A, B, C, D is a parallelogram. Plot D and give its coordinates. So A goes to B, B goes to C, C is going to go to D, and then D is going to go to A. So it is a parallelogram. What that means is the two sides, the top and bottom need to be parallel, and the two sides. So this is going to come out here and then come back so that you have two parallel sides this way and two this way. And how we know how far to go, that's the trick, is that the opposite sides of a parallelogram are the same length. So A to B is 1, 2, 3, 4, 5, 6 across 6 units. So C going to D has to be across 6 units. 1, 2, 3, 4, 5, 6. This is D. All right, so now I need to connect C to D and D back to A. And what you have now is a parallelogram. To make a parallelogram has 4 sides. Opposite sides are the same length and opposite sides are parallel. So DC and AB are parallel and they're the same length. DA and CB are parallel and the same length. All right, 17, you're going to plot these points and answer the next 2 questions. And that is it. I know this was a little bit long for a video, but we had to cover a lot of ground for lesson 9.1. You guys have a great day. Talk to you later.